Okay, so let's start to the last talk before the closing keynote. If you want to come to the talk Shift Left Security with the test pyramid, then you're on the right track here. What about me? I'm Andreas Falk. I come from Germany, so you may notice that from my German-English slang somehow. I work for a company called Novatech Consulting, so mainly doing IT consultancy. And my main topic here is about application security, container security, all kind of security stuff here. That's why I'm also part of the OWASP community as a member, and also I am a member of the OpenID Foundation, dealing with all kind of identity access management, like OAuth, OpenID Connect, all that fancy stuff. So you can reach me via Twitter or via email if you have questions afterwards. You're welcome to contact me at any time. So let's talk about the testing pyramid. So who of you knows the testing pyramid? So most of you. So this is a well-known thing. So if you're doing test-driven development, hopefully then you all know that you should have lots of unit tests as a safety net to enable refactorings and stuff like that. So without unit tests, it's quite difficult to see if you didn't break anything in your application. And as you can see here, you should have most of the unit tests and less of the service tests and even less of the UI tests. So if you go to top, then the tests get more and more expensive to maintain, to write, and you get really slow feedback time if you go on the top of the pyramid. So that's the original testing pyramid by Mike Cohn. There's an improved one, which I like a bit better than the original one, which was invented by Janet Gregory or Lisa Crispin in their agile testing book. They detail that this kind of tests usually are the programmer, the developer tests. These tests typically deal with API, service layer stuff, so even more business rule related or functional related. And on the top you have what's so-called workflow tests. So this typically must not be UI tests in all cases, so it can also be acceptance testing on the service level, for example. And on the top level, you have the manual explorative testing, so the tests you have to do with human resources, and these are typically not automated. So what about security? You rarely find anything about security on the testing pyramid. So the first thing that the typical developer notices when the developer gets into security is usually the OWASP top 10. So who knows the OWASP top 10? So probably most of you. Who knows the new version of the OWASP top 10? So this was published on 24th of September by the OWASP, and this is the completely new OWASP top 10 list. You will notice some changes here. So the number one thing, the injection, moved to number 3 now. So injection is not the most serious security problem anymore. The most serious problem nowadays is broken access control. So missing authorization checks on your REST APIs typically. So these are the most prominent problems nowadays in web applications. And they also introduced some new topics like cryptographic failures, or insecure design is a new one. And also a quite new one on the bottom list is server-side request forgery, which is also some kind of advanced server-side attack mechanism nowadays. You can look that up on the owasp.org page, so the new version. So unfortunately, there is no PDF available at the moment, so you can only look it up online on the web so far. But they have a pretty good description on each topic available already. So why do I stress the OWASP top 10 in the new version? Because of that insecure design. And that exactly is introducing the topic of today, because insecure design now speaks about you should use threat modeling, for example, to find flaws in your application, and also integrate the security language in each and every user story you write. And the central thing, what I will talk about today, is write unit and integration tests to validate that all the flows you write in your application are resistant to the threat model. So you typically do a threat model with all the threats that may be dangerous for your application, and then you write the unit and integration tests to prove that you are not, that these attacks cannot happen to your application anymore. And also compile use cases and misuse cases for your application. So why don't write a user story from the view of an attacker? So you write your business use cases every day, and you can just change sites and just also write a user story with a target that an attacker typically wants to achieve in your application. And the first thing you will notice is how to really find the security tests you need for your application. So this is a typical problem I see a lot in my customer projects. So the developer is asked by the manager, so please write an application, and the application must be secure. And now the developer asks himself, so what do you mean by the application must be secure? Then the next sentence that the manager tells the developer usually, so it should be compliant with the OWASP top 10. And this is also complete nonsense, because the OWASP top 10 cannot be certified. It's not a compliance issue there. So how to really find concrete security requirements for your application? And this can be done with some helpful tools, also by the OWASP community, and also by doing threat modeling. So usually you have some kind of business requirements. Maybe you have compliance restrictions, like in Germany with the BaFin, the finance regulations for banking and insurances. Or you have some regulations in the US by NIST, for example. Or you have to be ISO 27001 compliant. So these all kind of things also influence your security requirements, in addition to your business requirements. And then to really find the typical application-related security requirements, there's a really helpful document called the Application Security Verification Standard, also by the OWASP. So you typically get a PDF document describing a complete catalog of typical security requirements for your application, together with also samples how to really verify, to test these requirements. So this is quite helpful in requirements and also in testing purposes. A second guide you get is the Web Security Testing Guide, which is heavily used by typical penetration testers nowadays. So this covers all the web penetration testing contents that you get when you're using a Burp Suite or OWASP SAP tool. So this kind of thing is also quite helpful to really do security testing. And of course, the OWASP top 10 comes into play, but really at the end to just recheck if your security tests then also cover these typical OWASP top 10 problems. But you should not use the OWASP top 10 list for getting your security requirements. So these two guides are much more helpful to get the security requirements, and then from the security requirements, you get your security tests you have to write. Without any requirements, it's impossible to write the correct tests for these requirements. So for those of you who don't know threat modeling, so this is a simple sample of threat modeling methodology. There's also a complete manifesto, so everything today has to have a manifesto somehow. And for threat modeling, we always ask 4 questions. So what are we working on? So typically you get some architecture diagrams, some visual flows of your application, what you are currently building. You typically have some kind of data flow diagram you use for threat modeling. This is a very simple one. You have a login service, maybe running on the cloud. You have a user database, maybe running on-premise at your data center, and you have a user that interacts with that login service over some protocol. In that case, it's the insecure protocol HTTP. And here you have another protocol communicating with the database. And in between, you have what is called trust boundaries. With a trust boundary, you always have some change in user scope. So you have to use some kind of login at this boundary and another user login on that boundary. So you cannot use the same user here and the same user here for the user database. And the second step is then what can go wrong in your application. Then you try to find threads in that data flow diagram. You typically can also use some playing cards provided by Microsoft, the elevation of privilege playing cards. We have a really good experience with playing that cards because also developers that don't have any clue about security can use these cards to detect attacks on that data flows. And if you then detected the possible threats, then you can talk about what are we going to do about it, to find mitigations, and also ideas to derive tests that prove that your application is safe from these found threats. And at the end, we always do some kind of retrospective. Did we find all the threats? Did we do a good job? Should we have another session as continuation of that threat modeling and so on? So this is the application security verification standard. So it has lots of security requirements in that catalog. And this thing is also intended to be customized. So if you have typical applications that you write for your company that are quite similar, then you can customize this catalog. So you don't have to deal with everything here inside, but just the applicable content of that guide. And this guide includes helpful things like secure coding, also for DevSecOps, unit integration testing, standards and checklists, also architecture-related things. And it defines 3 levels of security. So level 1 is typically the really base level every application should have as a minimum. And typically only level 1 is testable by penetration testers in an automated fashion. Level 2 or level 3 are not testable by penetration tests because you also have architecture reviews, for example, and some hybrid reviews and much more sophisticated security-related things that you have to cover here. So typically, the standard application at least should fulfill level 2. If you have an application that deals with highly restrictive data like medical data or military things, maybe then you should also enforce level 3. What you also get is some kind of Excel checklist where you can also then go through this Excel checklist and check each and every security requirement that is applicable for your application. So that's also quite helpful. So now let's dive into the testing pyramid. We will start at the base level, the unit testing layer. Here you can already test for really different things, like you have the typical static application security testing, with lots of tools that you can have on open source world or commercial tools as well. Then you can check already for your third-party dependencies if these dependencies do not have any vulnerabilities. So Kubernetes is a big thing nowadays, so you can also test with container image scanning tools on operating system or application-related problems. And then on the unit test level, you can already check for missing input validation, for example, to avoid injection or cross-site scripting problems in your application. You can also test for parts of the broken authentication. I will show a sample of testing password policy enforcement later on. Then you can test also the typical unit test approach to bypass business logic. So usually with unit tests, you test for the business logic, that this is according to the specification. But you can also write negative tests that try to bypass the business logic and try to misuse that business logic. Also, you can test already here on that stage if you return stack traces from your functions, which is a bad thing. Also, that gives attackers more information than it is really needed. And also, you can also check for logging. For example, if your logs do not include sensitive data like passwords, secrets, or AWS keys, or something really strange. And on that level, you can also already test for your architecture. You can test if your layering is correct, if you do not have any invalid calls in your application, for example. So I will show you 3 different things of that possible tests, like the static application security testing, the architecture-related thing, and the broken authentication. So let's start with static application security testing. Nowadays, this is a good thing which I find in most projects, so at least static application security testing is done in most projects of my customers at this stage. So luckily there are lots of free tools available like Spotbugs, so the follow-up of the find bugs tool, which was outdated. Then you typically have the SonarQube. So if you have an old version of SonarQube, I could recommend that you upgrade to the newest version of SonarQube. So even in the open source version, they added really plenty of security-related stuff into that latest versions. So please upgrade your SonarQube, then you will get lots more security-related findings there. Also, there's some tool called SemGrep, which is usable for plenty of languages like C#, Python, all kind of languages, TypeScript, and so on. Then SNCC code is also quite useful. You get an IntelliJ plugin by SNCC that is also free of charge. You can directly click scan in your IntelliJ, and then it scans your complete application. Then for infrastructure as code, this also has to be checked as well as the usual source code. You typically have tools like Checkoff or Terrascan that do this job. So these 2 tools can also scan your Kubernetes stuff, like your Kubernetes YAML files, if these are according to the best practices of Kubernetes. So you should not use the root user in your YAML file, for example. And you should not switch on privileged mode in your YAML files for containers. Stuff like this is also checked by these tools. And then also check your Git repositories for secrets, for example, with Trufflehawk. It's a quite useful tool. And then, of course, check your third-party libraries with OWASP dependency check. According to the architecture and design, you can also test plenty of things already on that level. So the typical test you want to make with architecture is that your architecture pattern is not violated somehow. So typically you have some layered or onion architecture patterns that you use in your applications. And with that ArcUnit framework, you can easily test if no call is against that typical layered architecture, for example. But you can also test security-related things, like, for example, if you have password policies in place, if you have input validation in place. So here, for example, you can check for the bean validation constraint annotations that have to be in place on different locations. You typically can test for broken authorization stuff. So typically your Spring Security, the Spring Security brings some annotation like at pre-authorized into the play, and you can easily also check via architecture tests that these annotations are also located on the right places. And for SQL injection problems, you can also check for invalid calls to persistence APIs. So you can totally avoid direct calls to Java SQL packages and stuff like that if you have an ORM framework in place like Hibernate or Spring Data. And this is a section of the application security verification standard which deals about password security requirements. So with these requirements, you can easily derive a password policy for your application. So this is according to the latest NIST regulation stuff. So you should verify that your passwords are at least 12 characters in length, for example. And you should also verify that you can also make possible that users can use passwords with 64 characters, for example. So it typically annoys me when I use a service on the internet and the service tells me, oh, you can only use a password with a length of 12 at maximum at our service. So that's quite annoying with all these password managers you can use today. So one password you generate just 25 characters randomly, and the service tells me, oh, you cannot do that with my service. So that's bad. And also verify that password truncation is not performed behind the scenes. So that's really a serious problem. So if the user types in a password 20 characters long, you truncate that password, and the next time the user asks himself, so I did use the right password. So that's really strange. And also you should make possible that any character is permitted for your password. So according to the NIST, even emojis, Unicode is permitted as a password character. And also, very important, verify that passwords are checked against a list of breached passwords, like when password also does with the Troy Hunt's have I been pawned service, for example. Always do that as well. So let's check for some demo. So for those of you who don't know ArcUnit already, so this is a typical ArcUnit test that you can write. So this defines that I use a layered architecture, and my layered architecture has 3 levels defined by layered architecture. So some presentation level with the REST API, some business logic level with the services, and a data access layer for persistence. And you can define which packages define which level, and then you can just declare that some calls are allowed and some calls are not allowed on your application. And this typically is then enforced by that ArcUnit framework already on the unit testing level. And I can also do that for security-related things. So like, for example, I can also prohibit that any API or service layer can call any persistence call at all. So it's not allowed to use Java SQL or something like that in your business logic or REST API layer. And even in the data access layer, I also check that no low-level things like Java SQL, Java X persistence, or org Hibernate calls are allowed. So only JPA or Spring Data calls are allowed in that case. And with that, you can avoid nasty things like SQL injections by concatenating low-level Java SQL calls. So in my code that you can find on GitHub, I will show that URL a bit later. I've sneaked in lots of security problems by intention. So like, for example, I have put in some Java SQL SQL injection problem. So if you detect something like that one, so this is a typical SQL injection problem. So you get a name here as an input from the user, and you directly concatenate that input with your SQL statement. And here I use the low-level GDBC layer directly, which should not be allowed according to my ARC unit tests. And this is a typical SQL injection. So don't do that in your projects. And with my test, I run that test. So we should see that this test will fail, hopefully, yeah. So it failed with multiple things. So the rule classes should only access classes that, yeah, so it failed. So with that, you can directly detect problems in your code that has invalid calls to some illegal Java SQL calls. Another example would be to test for password requirements. Here I use a thing called bean validation, which is the standard in Java when you deal with APIs here. You can easily also instantiate a bean validation factory in your unit tests already. And here I then test if my passwords are according to the password policies. In that insecure branch, so I have no password policy in place in the insecure branch. So typically these tests should all go to red in that case. So I just try to create a user with some password that does not have 12 characters in length. I also test if a long password is allowed according to the password policy. And I also test if truncation is not performed as part of my application. And also I can test for emojis in my tests. If emojis are allowed, then my tests also should be green. And I can also test things like the user can change a password, and the user has to give the existing password as well to change a password. Some things cannot be tested on the unit testing layer, but you can also document that by disabling some tests with the remark that this test can only be tested on the integration testing layer, and you should then write a test on the integration testing layer later on. So let's check if these tests run successfully. I have run these tests beforehand so that it runs a bit faster. So this is a unit test, so it runs pretty fast. So for example, we have a test here. User sets passwords that are at least 12 characters in length. So I was thinking that I should not get any errors here in that test, no constraint violations, but in fact, I got one constraint violation. I got none constraint violations, so I wanted to have a constraint violation because of that mismatch in the length, but I did not get one. So you should have to implement that password policy here. So this has been some examples on the unit testing layer. To take a photo. So the next layer would be the service testing layer. On this layer, we can even have more tests for security. So we can use tests on the input validation that's already triggers on the REST API level, for example. So if I run a Spring container, then I can also test on the REST API level and also test for constraints at this stage. Then I can typically also run authentication, authorization tests. So for example, Spring Security provides a really sophisticated testing framework for doing all these kind of automated tests for authentication, authorization. Regarding authentication, so more and more people use JSON Web Tokens with some OAuth OpenID Connect server. Here you can also easily run a testing container, like for example for Keycloak, then configure that test container as similar to your identity provider that you use in production. And then you can also easily integration test your JSON Web Token authenticated basis with a test container like Keycloak, and you are more into production-like fashion. So the other thing is that you can simulate JSON Web Tokens with self-signed JSON Web Tokens and test it that way without an identity provider, but that may sometimes cause problems because you have different JSON Web Token than using in production. So I would always advise to use a testing container like Keycloak to also test for JSON Web Token authentication. Then you can completely automate your authorization checks for your permission model. You can also test your session management that you use if the session identifiers are really random identifiers, or you can maybe guess the session IDs. So especially if you have implemented session management yourself, which I would not recommend, then you should also have session management tests as well. You can also test for output escaping stuff, so that your REST API already takes care that inputs are not directly reflected without any proof to the result. If that is the case, you could have a problem on your front-end side with cross-site scripting. You can also already make sure that you use some output escaping on your REST API that escapes the dangerous characters before getting the result back. And you can also already check for SQL injections in your code with integration testing. I will show that later on. And also typical misconfigurations like cross-origin resource sharing problems. So these are 3 examples that I have in code. Here again you have some example how the application security verification standard deals with some of these requirements. So here you can clearly get the requirement that you should enforce access control on a trusted service layer. So I would say you should restrict that on multiple service layers, like on the UI layer, on the service layer, and even on the data access layer. So if one layer has been broken by some attacker, so attacker could manage to get around URL-based authorization stuff very easily with some strange encodings and nasty stuff like that. And if you have a second layer on your business logic that also proves for authorization, then you're safe from these typical layer 1 problems that we are facing. And also always check that you follow the least privilege pattern, so no user should get more privileges than the user typically needs for the typical use cases the user wants to achieve. And also this is sometimes a big problem, verify that access control fails securely. So in case of any problem, any error that happens to your application, don't allow all users to come into your application by accident. So also this can be checked, for example, with load testing, for example. So if you have really high load on your application, then your access control still should not fail. So it should deny all users in case of an error. So again, some demo time. So here I have prepared some tests, like for example for the SQL injection stuff. So for SQL injection, writing tests is quite easy. So as mentioned, I use Spring Boot, Spring Data here in that flow. And this is a typical payload you use for detecting SQL injections. This is a payload you can put inside every input field you find in your application, and then just check if you get some error message back from the application. So if you get some error message, then you probably have a SQL injection problem. And if the application is really bad, it may be possible that you get all the data from the complete table back with such kind of payload. And you can easily just drop in that payload in each and every test in your application. So like I did, for example, for that search bookmarks here. So I just put in the SQL injection payload in the search operation, and what I would expect with that payload is that the result should be empty. So it should not find any matching data in my bookmarks. So let's see what this test does. So this takes a bit longer because that's integration test that is run now. So let's see. So it went red, so not successful. And what we can see here, it was expecting an empty result, but this is a typical error of SQL injection. So it got the complete contents of the table back, so all the bookmarks that are inside the table. And you can easily write such tests to prove that you don't have any SQL injection problem in your application. So with JUnit 5, it's quite easy to push different payloads inside your test. You can even load these payloads from files. And you can get plenty of files on the internet with so nasty payloads like cross-site scripting payloads, SQL injection payloads, other strange payloads that you can just put into your operations and see what your application does with that payloads. What else do we have? So we have that typical tests also for cross-origin resource sharing. So lots of developers are a bit lazy, so putting in wildcards as a cross-origin resource sharing. So in that way, you then drop all these web browser security mechanisms like that same origin policy with that wildcards. That's also all gone, and every client could just call with AJAX requests to your backend. And so avoid wildcards on your cross-origin resource sharing as I did here. Let's see. I have it in my config. So this is the thing you should not do. I just put in a wildcard as the origin, and so typically all the front ends are allowed. And with such kind of tests, you can also easily prohibit these things. So just test for different origins, like an invalid origin. In that case, I have used evil.com, but my allowed origin would have been localhost 3000 if it was an Angular application running locally, for example. And you can easily also test for these kind of things. So for time reasons, I have to skip the other things here. So the last automated layer you can test is the dynamic application security testing. Here you find typical tools like the OWASP SEP tool, which is a proxy tool that you can also download for free from the OWASP site, which is also used heavily by penetration testers nowadays. Compared to the Burp Suite, which is the most used tool of the penetration testers nowadays, so these are quite comparable in functionality. So my wish would be that every developer not only has IntelliJ or Eclipse at his workplace, but next to IntelliJ or Eclipse has installed OWASP SEP as a penetration testing tool and just locally also tests the REST API with that tool. That's quite easy to learn. So here's quite easy to learn UI. You find plenty of videos on the internet with tutorials on that tool. And then you can regularly also test your REST API for SQL injection, patterns for cross-site scripting problems, and etc. You can also use specialized tools like SQL Map for detecting SQL injections, or Nmap, for example, for checking your infrastructure as code. So if you have created some infrastructure, you can easily test with Nmap if only these ports are open that are intended to be open, for example, with your Terraform. And also, you can use Gatling load testing to detect problems with securing failures. So fail securely with your code. You can also test that with load testing, for example. So with OWASP SEP, you can have also a container-based scan, which can be put easily into your ICD pipelines. There are 3 variants that you can use: a baseline scan, which only does some fast passive scans. So this is quite secure. So it just uses your regular URLs and calls these URLs and then checks the responses for some pattern matching things and can detect, for example, if you're using basic authentication, which you should not use in serious applications anymore, or you miss some security response headers in your responses, so typical things that are found on that level. So this runs pretty fast and can easily be put inside your CI/CD pipeline for every commit. So it just runs almost 1 minute and it is done. The next one is the API scan, which is quite useful for REST APIs. You can just put in some open API specification, then this tool knows all the URLs that it can check, and then it just calls that URLs specified by OpenAPI with SQL injection, all these typical problems. And you can have a full scan, but that full scan is not advised to put into the regular CI/CD system, because depending on your size of your application, this can probably run for hours. So please put that one into your nightly builds, for example. So I can also show some example for that. So let me check on the terminal. I've already started my application, so this is the application, so I have to log in again. So to be sure that it scans the intended application, you always have to check if your application is running on that intended local IP address, because you cannot use localhost with Docker containers. So in a Docker container, localhost is a different context. So always make sure that your application is running on the correct IP address. So I made sure that this is the case. And then I just have some script here to start the API scan. So I changed that IP beforehand. And now let's try to run that. We will have a look at that a bit later, because that takes some minutes to run. So at least it started. So this up to that stage, you can automate all that things in the security-related world. So put static code analysis, dependency check on the first stages, then do an image scan if you're running containers in Kubernetes. Then you deploy your application to Kubernetes cluster, and then you can put in a dynamic security scan using SAP tool. So these things can all be automated up to now. The top one is the manual testing. So here you should typically do security code reviews. These are really important. So do not only perform your common code reviews, but also try to put in security-related stuff in doing your regular code reviews. So if you're doing merge request stuff, then also look for security. Then you can also do explorative testing using security charters. And of course, you have the typical pen tests on that level. So this is an example of an explorative test charter. So I want to explore some special functionality in my application with injection attacks to discover some security vulnerabilities. I can also use for this kind of tests some useful plugins, browser plugins like the bug magnet plugin. With that plugin, you can just have a right click on the mouse on an input field and then directly have access to lots of different payloads like SQL injection, cross-site scripting stuff, strange encodings that you can directly try out on each and every input field. So this is quite a useful tool. Then according to penetration tests, so this picture shows an attacker that works 24 hours, 7 days a week. So the attacker typically does not care about your holidays, about your project times. And on the bottom, you have a typical continuous deployment approach. And in between, you typically find some rarely executed penetration tests. So this is the pattern I often see at my customers, unfortunately. But this effort does not scale anymore today. So if you deploy every 5 minutes on production, then you have a blind spot according security. So if you're doing yearly penetration testing, so that would not be sufficient. So that's the cause, the reason why we should do security testing ourselves. So we cannot rely on penetration testing anymore. So if you have half-year releases still, then you may rely on penetration tests, but with the modern applications, the CI/CD approach, this does not work anymore. So as a summary, put in security on each and every layer of the testing pyramid. So like I have shown as examples, you can easily put tests for almost all OWASP top 10 problems in your security testing. And so every talk should have a DevOps slide. So this is mine. So DevOps, the sec is silent. So we don't call DevSecOps anymore. So the security should always be part in the DevOps approach. And I want to call that the devs and security, vice versa, should show some empathy, vice versa. So why don't try to put a step into the daily work of a security professional, and also the security professional should try out to work as a dev one day. So then we might have much less problems with communicating with each other, because that causes real problems lots of the time. So the developer argues, I have no time for security, and the security guy, the developer, does not have any clue about security. So these are misunderstandings we should avoid. And now we should also have the results, yeah. So as shown here, we have different problems detected, like cookies missing same-site attributes. So these are warnings but really nasty problems. Also detected a SQL injection in our search requests, and also some cross-site scripting weaknesses, because I reflected just the results back which you should not do usually. And with that, I'm at the end of the talk, and I think we don't have any time for questions anymore, so time's up, unfortunately, but maybe one question. Yeah.
So I was just wondering, I know you talked about password policy requirements. Should local environments always have password policy requirements? Or, because obviously you have them for all of your deployed environments, but how about local as well, for databases?
Also, if you only have local, even for local ones, yeah, these passwords tend to flow also into production or testing systems. So that's quite dangerous. So that's why I also would recommend to use it everywhere. Yeah. Okay. So thank you very much.